So today we're solving the cubic equation with algebra from the 16th century. So our equation is x cubed plus 2x squared plus 10x is equal to 20. So the first thing we're going to do is bring our 20 over so that we have everything on one side, giving us x cubed plus 2x squared plus 10x minus 20 is equal to 0. Now, in order to use the methods that we want to use, we need it to be in the form of x cubed plus px is equal to q, meaning we have to get rid of this x squared term. So the way that we need to do this is by a change of variable. So what we're going to do is we're going to let x here be equal to u minus 2/3. And the reason that that we chose this is because this will get rid of our x squared term. So substituting this in will give us our u cubed plus, and now our x squared term is gone, so it's going to be 26 over 3u minus 704 over 27 is equal to 0, which has the form of the u cubed plus, in this case it's going to be pu, is equal to q, because obviously we replaced x with u. So it's going to look like u cubed plus pu is equal to q. And this is going to be our p, where it is 26 over 3, and our q is going to be equal to 704 over 27, because it becomes a positive q, because we take this whole term, and if you look, it's u cubed plus pu, and the q is back on the right side. So we move this back over, giving us the positive value. Now for the Cardano's method, we have our form already because we need it in the u cubed plus pu plus q is equal to 0, and we already found what our p and q is equal to. So his solution was that u is equal to the cubed root of negative q over 2 plus the square root of the discriminant plus the cubed root of negative q over 2 minus the square root of the discriminant, where the discriminant is equal to q over 2 squared plus p over 3 cubed. So now we already know what our values for p and q are, so we're able to just plug them in, which is going to be 352 over 27 all squared plus, now this is going to be 26 over 9 all cubed. So now you could solve these separately, or you could just put it all in your calculator just to give us the final answer, which is going to be 5,240 over 27, which now we have the square root of the discriminant, because that's what we're looking for in our equation, which is the square root of that number. And now we're able to solve for everything in our formula up above. So creating a little space on the side now. So we're going to have the cubed root of this is going to be negative, and this is going to be our 352 over 27, just like it was for our q over 2 before. And then this is plus the square root of 5,240 over 27. And now you're going to add this with the cubed root of negative 352 over 27, but this time it's minus the square root of 5,240 over 27. Now, putting this massive equation into a calculator will give us that u is approximately equal to 2.036. But we're not done, because we're still in u values. In our original question, we had x values. So changing it back to x values, we set x is equal to u minus 2/3, because that's how we set x in the first place. So now this is going to be equal approximately to 2.036 minus 2/3, which gives us an x being approximately 1.369. Now, this is our only real root, but there is another way to get our more complex roots. So using our one real root, we can have it set up as x cubed plus 2x squared plus 10x minus 20 is approximately equal to, now if you factor out our new root, which is our x minus 1.369, and multiply it by the remainder of what our equation gives, which is our x squared plus, now this will be 3.369x plus 14.612. Just like how you did in synthetic division, where you found a root and then you factored it out so that you have a quadratic, so it's easier to work with. That's the same thing we just did, but this time our root isn't a whole number, it's just a little more complicated. So now all we have to do to find our other roots is just solve this quadratic. But if you put in the quadratic formula, you'll find that x will approximately give you two numbers, negative 1.685, and it's going to be plus or minus, and now 3.435i, due to a negative under the square root. So now, because we found all our roots, and we have a cubic, which means that we need 3 roots, we're able to list them all. So our first root, being our one real root, is 1.369. Our second root, which is a complex root, is going to be negative 1.685 plus 3.435i. And our final root, which is another complex root, is negative 1.685, but this time it's minus 3.435i. Now, there's another way that you could do this using Khayyam's geometric method, which we could go over in another video, but otherwise you could stick to Cardano's algebraic method, which will give us a final answer. So if you like this video, please let me know what else you'd like to see, and I'll see you in the next one.